Hello, welcome back to Mathematics FIS 1021. Right, this week we are going to discuss about the limits and their properties. So this is the first chapter under the calculus. So for calculus, we are going to discuss differentiation and also the integration later. All right, so this is just the introductory, all right, before we enter into the differentiation. Okay, so now we are going to learn uh, how to estimate a limit using a numerical or graphical approach. All right, so the second objective is to learn different ways that a limit can fail to exist. All right, so at the end of the chapter, you should know how to actually estimate a limit and also learn that how a limit can fail to exist. Please come back and check after you go through the topic. Okay, now introduction to limits. So what is limit? The limit is actually defined as the behavior of function, right, which is always we label as y, all right, when the x is approaching to a value. Okay, so what is the keyword here? The keyword is the behavior of the y. So we want to know when the x is approaching to a value. Now, what happened to the value of y? Okay, so we are going to start a discussion using this function. Okay, so now we can from this function here. Okay, what happened if the x is 1? Okay, if the x is 1, so we substitute 1 into the function, we will get 0 over 0, right? So from here we know that the y is actually undefined. So the y does not exist. Now, however, right, we want to know what happened if the x is getting closer to 1. Okay, what happened to the y? Okay, what is the behavior of y when the x is getting closer to 1? Okay, so we use the concept of limit. Right now, so if we perform the calculation, now when the x is 1, all right, the y is undefined. So we perform the calculation when the x is getting closer to 1, all right, or when the x is approaching 1. So now there are two sides, right, we can consider, right? We consider from the left-hand side here, all right, the left-hand side, when the x approaches 1 from the left, so we increase the value. Okay, we start from 0.75 maybe, all right, then 0.9, 0.99, and 0.999. So from here you can see, right, the value of x is actually getting closer to the 1 from the left hand side. Okay, so you imagine this is the graph. All right, this is the x and the y. So this is 0. Let's say 1 is here. This is the value 1. So when the x is getting closer to 1 from left hand side, so we have 0.9, 0.99, and 0.999. Okay, so we calculate the value of y. All right, so what can we say about this value? Okay, what can we say about the y when the x is getting closer to 1 from the left? We say the value of y is approaches 3, right? So we can see the y is getting closer to 3. Okay, now then let's consider from the right hand side, from the other side, from the right hand side. So we can use 1.25, start with 1.25, then 1.1, 1.01, and 1.001. Okay, so all right, the value of x is getting closer to 1. Now, for y, right, the value start from 3.8, then 3.3, 3.0, 3.003. So we can see from here that when the x approaches 1 from the left, the y also approaches 3. Okay, so what is our conclusion here when the x is approaching 1 or approaches 1? So we say the y approaches 3. Okay, so for mathematics, this is how we actually write the situation. We use this concept limit. We say limit of fx when the x approaches 1, when the x approaches 1 is 3. Now, what does that mean? So it means that when the x approaches 1, the behavior of y actually approaches 3. Okay, when the x is getting closer to 1, what is the behavior of y? The y is getting closer to 3. Now, from the graph, right, we can actually see, right, it's something like this. So when the x is 1, the value of y is undefined. So you can see there is a white dot here, right, to show that the value of y is undefined when the x is 1. Now, however, when the x is getting closer to 1, the y is getting closer to 3. Okay, so this concept is called limit, and we read this as the limit of fx as x approaches to 1, approaches 1 is 3. The limit can be written as this form, right? So the lim here refers to the limit. The fx is the function, right? So when x approaches c is the value, and the L refer to the y approaches to L, right? So when we see the notation like this, it refers to the limit. Now let's consider example 1, right? We can estimate a limit using a numerical number, right? So let's evaluate this function, x over square root of x plus 1 minus 1, right, at several points near x equals to 0, right? And we can use the result to estimate the limit. So we can perform using a table. Now we can see here, right, when the x approaches 0, so we are going to test from two sides, right? First from the left hand side and then from the right hand side. So from the left hand side, so we can start with negative 0.01, negative 0.001, and negative 0.0001. So we substitute the value into the equation here, right? For example, the x is 0.01 negative, right? Then we perform the calculation, we can get the value of y. Okay, so after that, right, by looking at the value of y, we can deduce that, all right, the y is actually getting closer to 2, right? So we say the fx approaches 2, right? So this is from the left hand side. Now, from the right hand side, we can start with 0.01, then 0.001, 0.0001. So we can see here, actually the x is getting closer to 0 from the right hand side. Now again, we substitute the value back to the function here to perform the calculation and to find the y. So we get this value of y. Now the conclusion here, right, we can say that the y is actually getting closer to 2 as well, right? So we say the fx approaches 2 when the x approaches 0 from the right. Right, to combine these two, now we can actually say that, all right, so when the x approaches 0, fx approaches 2. So to write has limit, we can write the limit x approaches 0, fx, right, is 2. Okay, so right, so if we examine the situation from the graph, so this is the graph of the function. Now at this point itself, when the x is 0, the value is undefined, right? Because when the x is 0, we have 0 over 0 plus 1 minus 1. So we have 0 over 0 here. So the value of the y is undefined when the x is 0. Now, however, right, from the graph, we can see that the y approaches 2, right, this value is 2. The y approaches 2 when the x approaches 0. Next, now we are going to see under what situation the limits fail to exist. Now let's consider this function, all right, absolute of x over x, and we want to show that the limit when x approaches 0 for this function, right, does not exist. Okay, so first let us consider the function. Now when we consider the absolute of x, we know that the absolute of x is x when the x is more than 0, and the absolute of x is negative x when the x is less than 0. Okay, so when the x is 1, the absolute 1 is 1. Okay, so when the x is more than 0, right, we just take the x. Now, however, when the x is less than 0, let's say negative 2, then we are going to, all right, absolute of negative 2, right, we are going to apply a negative to the value and make it a positive, because absolute means that distant, right? So we do not have negative nor positive. So we apply a negative, therefore we have a negative x here. Right, so now when we have absolute of x divided by x, so let's consider this one. Now when the x is more than 0, then we have x. Okay, when the x is more than 0, then we have x here, this x, over x here. All right, so we have 1. Now, however, when the x is less than 0, so for x less than 0, we are going to take negative x for absolute of x. So here, when the x is less than 0, then we have negative x over x, then we get negative 1. Okay, so for this function, right, so we can define, right, the y is 1 when the x is more than 0, and the y is negative 1 when the x is less than 0. When the x is 0, it is undefined. Okay, when the x is 0, it is undefined. So when we sketch the graph, so we can observe that the graph is actually something like this. Okay, so the graph will be 1 onwards after when the x is more than 0, and negative 1 when the x is less than 0. Okay, so now what happened, right, when the x is approaches to 0? Now from the left hand side, we can see here, right, from the left hand side, when the x approaches 0 from the left hand side, now I put a negative here to show that when the x approaches to 0 from the left hand side, the y approaches -1, right? So when the x approaches to 0 from the right hand side, so I put a positive here from the right hand side, what happened to y? The y approaches to 1. Now we can see these are two different values, 1 and -1. Now in this case, since these two values, right, the x does not come to one value, we say, right, the limit of fx when x approaches 0 does not exist. Okay, so any situation when the limit of x from the left hand side is not the same as the right hand side, we say the limit does not exist. So this is the common type of behavior associated with non-existence of limit. Right, number one, the fx, the function approaches a different number from the left side of c than it approaches from the left side. Now it means that from the right side and from the left side, the function approaches different number, so the limit does not exist. Number two, fx increases or decreases without bound as x approaches c. Alright, so now what does that mean? Alright, it means that now let's say this is the value of c is here. Now when the value of x go to infinity or negative infinity, alright, when the x approaches c, so we also say the limit does not exist, right? So it means that the c is actually an asymptote. Okay, so the fx oscillates between two fixed values as x approaches c. All right, so if the x, when the x approaches c, all right, the value of y, all right, oscillates means that one positive, one negative, one positive, one negative, one positive, one negative. So if this is the situation, the limit does not exist as well, right? So this is how the three situations when the limit of x, the limit of function x does not exist.